This is a demonstration of the Symmetric graph tool. The tool is taking as an input the unadjusted matrix of a graph in CSV format, and it's outputting a graph using the maximum visible symmetry. The graph is using the tool is using the automorphism of a graph to plot the graph more symmetrically. So here we can see we have 5 different layouts. The only layout that uses the inherent symmetry of a graph is circular. If you choose the circular, you have also the ability of having additional aesthetics, which is the reduced crossings, the edge crossings. So you can also choose this. So let's see. Here we can see that we have the file explorer where we can choose our CSV file. So we have plotted our graph. The graph is plotted in two different circular sectors where the points that are non-fixed by the automorphism are plotted on the right and left hand side. This graph is of order 2, meaning that the non-fixed points are in pairs, and in the middle, on the main vertical axis, we have the points that are fixed by the automorphism. So we can see that we have chosen the reduced crossings option. So the graph now it's plotted using additional aesthetics, where as we can see the vertices are positioned in a way, for example, vertex 5 is only adjacent with 18 and 19, so it's plotted at the end, so it can have an inherent symmetry. Here we can see exactly the same graph without the reduced crossings option enabled. We can see that the vertex 5 is very high in the middle of the graph. So we can see that it has huge edge crossings in comparison with before, and more specifically 12 different edge crossings. So we have the ability to export the graph by clicking this, and we can export it in various formats. If we want, we can also adjust the adjacency matrix here by clicking to any and changing the values. So, and then we can click the change button. So we can change the graph and plot a new one. So as we can see, the new graph does not have an adjacency, an automorphism. So as we can see, the new graph does not have an automorphism, so it's plotted in a basic circular position. So as we can see, the new graph does not have an automorphism, so it's plotted using a basic circular layout. The software also supports saving a graph. The software supports other layouts like spectral, spring, and random. This is an example of a spectral graph. You can see that you can move around the adjacency matrix. So you can move with the scroll bar. So yeah, that's it. And when you're finished, you can exit the tool by clicking exit. And when you finish, you can exit